All right, starting off with slide 1, with the first 4 slides, we're doing something very similar. So it says draw 2 waves, so that each wave would have the same pitch but a different volume. So what I want to start with, probably the easiest way for me to do this in each one, is we're just going to draw a wave that we can use to begin with, and then we can change that one for comparison. So I'm going to choose to make a wave that has a wavelength of 4 and an amplitude of 2, because that kind of seems like some easy numbers to do. So let's remember that a complete wave is going to need to go up, down, and then back. So if my wavelength is 4, that means it's going to half the wavelength is going to be 2, so that's where it's going to be crossing. So then my crest should be at the 1. I've selected the curve tool, so I'm going to click here. I'm going to go up 2. I'm going to go down 2, and I'm going to leave that there. So that's my first wave that I can use as a reference. So the next one says I want them to have the same pitch but a different volume. So I need to think, how do I go about changing the volume if this is supposed to be representing a sound wave? If this is representing a sound wave, then the volume has to do with amplitude. So I need to keep keep the pitch the same. The pitch has to do with wavelength and frequency. So the wavelength needs to stay the same. I just need to make this either taller or shorter. So let's make it louder. It sounds more fun. So I'm going to go, actually I'm going to undo that. I'm going to start on the 7 just to keep my numbers in the right place. Makes the math easy. So if I start on the 7, then if it's the same wave, it would go up to the 8. So I'm going to make it louder. So I'm going to go up, I'm going to go back down 4, because we need the height and the down motion, or the direction, to be the same. And so those would be my 2 waves. I'm not going to type in the explanations because you guys should be able to do that. So I've got 2 waves. They have identical wavelengths, so that's going to give them the same pitch, but they have a different volume, so this one's going to be louder. If we move on to the next one, I want to do the same volume but with a different pitch. And so this first one, if I just keep, there's no reason for me to complicate things and make a different wave every time. So I can just make this one look exactly like I did on the first one. And then over here, I want it to have a different pitch. If it's got a different pitch, then it's going to have a different wavelength. It says it wants the same volume, so I still need to have the same amplitude. And so the only thing I need to change on this one would be the wavelength. So previously I had a wavelength of 4. Maybe on this one I can have a wavelength of 2, so I can just shorten it up. Again, I'm going to go to the same height. And these would be 2 waves. Again, if I put an explanation up here, which is what I want you to do, these are going to have the same volume because they have the same amplitude, but they're going to have a different pitch because they have different wavelengths. We go down to this one. This one says, let's do the same brightness, but a different color. Brightness has to do with the amplitude, and color has to do with wavelength. So again, I can start this off just like the other ones. So that's my reference wave. And if I want it to have the same brightness, then it needs to be the same height. But if it's a different color, that's going to change the wavelength that we have on here. So just kind of like the one I just did previously. Oops. Don't like that, how that worked. Let me undo and start over. Good thing to be able to do. Undo. So I could explain that these would be 2 different, if these were light waves, representing light waves, this would be 2 different colors. This would be a shorter wavelength, so this would be towards the violet end, and this would be a longer wavelength, so it might be towards the reddish end. Again, we've got the same amplitude, but a different wavelength, so we're going to have the same brightness and a different color. If we go to 4, it reverses it. So again, we want to have a reference wave that we can start with. And if it's the same color but a different brightness, that means we're going to have the same wavelength but a different amplitude, kind of like when we change the volume on the sound wave. So if it was brighter, maybe it goes up to 4. And so these would be the same color because they have the same wavelength. but excuse me, they have different amplitudes, so they would have different brightness. If we go through here and answer these, hopefully you understand that by looking at these, we know that these should be transverse waves because of the way that they're drawn. Longitudinal waves look more like a slinky that would be, or a spring that would be compressed. But let's remember in real life, both of these wouldn't be transverse waves. Longitudinal waves are the ones that have compressions and rarefactions. And if you remember back to the video we watched about sound, sound is the one that actually travels in a longitudinal wave. Therefore, representing sound this way is a little bit incorrect because sound waves don't travel like this, but it does help us to visualize the sound a little bit better. So in reality, what we would want to look at is if we actually drew a sound wave that looked like this, the compressions would occur at the crest, and the rarefactions would occur when we got to the trough. So again, this is an area of really high energy. We consider this to be an area of low energy. But again, the longitudinal waves are a little bit more difficult to draw than the other ones. All right, we recently talked about how waves interact with one another, so I ask you on this one, it said let's illustrate constructive interference by drawing two waves to the left of the dividing line and the resulting wave to the right. So what we want to do here is I want to draw two waves, and I guess we could draw them on top of each other. We don't necessarily have to. We could, let's see if we can maybe start at the two. Actually, I'm going to draw one above the line and one below the line. So let's go, we'll start at the 2, we'll go up to the 4, down to the 2, up to the 4, let's just make it here. That's not perfect, but it's good enough for now. And then down on the bottom, let's draw a similar wave, because if we do constructive interference, then these two waves should look the same. So I'm going to go down here. I'll just start at the 3 in this case, and I'm going to go up, and I'm going to go down, and I'm going to go back up, and I'm going to go back down. So with constructive interference, we should have two waves that are identical, or when we draw them, they're going to be roughly identical. And the idea is that if these two waves interacted with one another, if they came together, then we would get a resulting wave. And then that resulting wave should take into account how each piece of one wave interacts with each piece of the other one. With constructive interference, we've got a crest and a crest in the same place, and we've got a trough and a trough in the same place. So those are going to get magnified. So we're going to turn this into a resulting wave. So in this case, our amplitude is 2. And so if we have an amplitude of 2 and an amplitude of 2, then our resulting wave should have an amplitude of 4. Our wavelength shouldn't change. And so in this case, I've got a wavelength that's approximately 3. So let's come over here and draw. If I start at the 7, if it's got a wavelength of 3, it's going to come back through at the 10. And it's going to go back through over here about halfway through. So the big thing about this is make sure we get our amplitude right. So I had 2 and 2, so I'm going to go up to 4. Let's see. And then I'm going to come down. And then if I wanted to keep doing this, I could go back up. And this would be my resulting wave. I could, to make it look exactly like the other one, I probably should have come back down and done one more. But that's okay. The idea is that we're going to take these two waves, each of them having an amplitude of 2, and creating a wave that's going to be much larger than the one that we started with. If we go to the next slide, which is destructive interference, it's going to be similar. I'm going to start with one wave. Again, I'm going to start at 2, and I'm going to give it an amplitude of 2. So I'm going to go up to 4, down to 2, up to 4, and like this. So with destructive interference, we're going to have an opposite wave. So we're not going to draw it like we just did on slide 6. We're going to start, but with this one, we want it to actually go in the opposite direction. So if I start at -2, just so I can have a second wave, I'm not going to go up with this one. I'm going to go down with this one. And it needs to be, if this one's got an amplitude of 2 up, this one's going to need to have an amplitude of 2 downward. So we're going to anchor it here, and then it's going to come back up. So it's got a crest here at 2, and then it's going to come back down, and then it's going to come back up. All right. So these would be two waves that were opposite to one another. So if these two waves interacted, if a wave that looks like the top one and a wave that looks like the bottom one hit one another, what would be the result? Well, the result would be basically, in this case, the wavelength's 4. So our result would simply be, I was going to try to draw a line. A line. It's not quite straight, because the waves would cancel out and there would be no crest, there would be no trough. This +2 and this -2 would result in a 0. And I didn't put it on this line just so that we could see it a little bit better. So if I want to thicken that up so we can see it a little bit better, I can. And you can do that with any of these waves. If you want to make the lines a little bit thicker, you just come up here and click on that to make them a little bit more easy to see. Okay, so this is our result for destructive interference. Number 8 is we're looking at reflection, and hopefully we know with reflection that's just going to be light bouncing. So let's go back to our notes to be able to answer that. I'm not going to draw out 8, 9, and 10 because you should be able to go back to the notes that we had for this to be able to do that pretty easily. So an illustration of reflection, again, we could use some of the tools up here. If you wanted to use to make a line for a surface, you can choose that. If you want to use arrows to indicate the light hitting something, that's probably the best choice. Slide 9 is doing refraction, so again the same thing, you might want to use some of the tools that we have up here. And then 10, diffraction, same thing, you want to be able to illustrate it with some of the tools that we have up here, and diffraction might get to be a little bit messy. But again, let's go back and look at the notes that we hopefully took this week, some of the sketches you made, and if you don't have them, those notes are posted on eClass and on Google Classroom.